The question was saying that we have a boundary here, and on this boundary we have wavefronts arriving at an angle of about 30 degrees to the boundary. Something like this, 30 degrees to the boundary. Okay, so just so that we understand wavefronts are like this. Okay, let me restart there. Wavefronts are something like that. Then we have something like that again. So wavefront is a line joining the crest, line joining the crest, line joining the crest. So this is wavefronts, line joining the crest, meaning that along all this part here, there are particles vibrating. There are particles of this wave that are vibrating along this, all this. There are particles of this wave that are vibrating. So the question is asking us, because it is obvious that a particle here and a particle here, they are not arriving at the boundary at the same time. If we consider this, consider that the wave is moving in this direction. That's the direction of movement. So which means that even here, the wave is moving in this direction like this, which means that this part arrive here on the, what is it? On the boundary, red boundary there, before this part. So this part arrives at the boundary before this part. So if that is the case, that this part, which I will label A, arrives before, let's say, B. The question is asking us, and I shall revert to the question right now. Let me revert to the question. The question, this is not the question, but the question is saying, given the given diagram shows a parallel water waves of wavelength 10 meters approaching a straight sea wall. The angle between the wavefronts and the wall is 30 degrees. Which of the following is the first difference between the waves at 2 points 5 centimeters apart along the wall? So let's suppose that we have those 2 points 5 centimeters apart along the wall. So that's what I'm going to do here. 2 points 5 centimeters apart along the wall. So let's consider this point here to be 5 centimeters apart from this point. If this point is 5 centimeters apart from this point, then we can agree, and we want to find the first difference between a particle, this point which has arrived here, and this point which has arrived here. Now, to find the first difference, in other words, we are trying to find the angle at which it lags. In other words, we are trying to find the angle after which it arrives. So if this is point A, let's call this one C. We are trying to find particles that are arriving at point C, 5 meters away from point A. At what angle are they arriving? Now, this might not make so much sense, but when things are arriving 360 degrees later, it means that they are arriving in phase. In other words, they are arriving at this particular point, at point C, when the particle or the point which arrived at point A is almost doing the same things as the point that is arriving at point C. So in that case, they'll be arriving with a first difference of what? Of 360. But here we are looking for the first difference, or the angle at which these particles at 5 centimeters at C, 5 centimeters from A, are arriving. So we want to know how much are they lagging behind those particles arriving at A. So the best way is to draw a horizontal line like that. So by drawing this line that I've drawn, the green line, all particles along this line are all in phase because they are all representing particles doing the same things at the same time. So if I were to draw now this point here, this point represents a particle which is going to arrive at point A at some time. But that particle is in phase with the particle which is arriving at point C. So we want to know the first difference between this particle at A and this particle here. If you can find the first difference between these two particles here, we have found the first difference between this particle and the one arriving at C. Because at C and this one are in phase. In fact, all the particles along this line are in phase. So if we can find the first difference between this point and this point, then we would have solved half of the story. So what do we do now? We know that from C to A, there's 5 centimeters there. If there is 5 centimeters there, then what next? We need to know the distance here between these two particles here. So to know that distance, we know that on the other side here, there is 30 degrees. So the question is, what about the other angle here? Now, just to make it clearer, we can say that this is our horizontal line. The angle there is 30 here. If the wavefront is moving like this, sorry, this is the direction of movement of the wave, then we want to know this angle here. So it is obvious that this direction of the wave and the wavefront are at 90 degrees to each other. So if there is 30, then this one will be 60. So we are going to have 60 as our angle, which I'll try to put in blue here. The angle there is 60. So to find this, what would it be? Considering this will be the hypotenuse, and this one will be the opposite to this angle of 60, and this one will be adjacent. So in other words, to find it, let me call it x. To find x is adjacent of hypotenuse of 5 is equal to cos 60, in which case x will be equal 5 cos 60, which gives us 2.5. So the distance between this point, which I'll try to put in yellow, this one, and this one, this particle and this particle, the distance is 2.5. But remember, I said that this particle is in phase with this particle. So if this particle is in phase with this particle, well, then the first difference between these two particles is the first difference between this particle at A and the particle at C. So that's what it means then. Therefore, the distance x is 2.5. So the first difference, phi, is equal to then 360 times x, which is 2.5, over the wavelength, which is 10. So that would be a quarter of 360, which is equal to 90 degrees, like that.